Hi students, this is Reema. Hope you're doing great. So today's video we'll be seeing some textbook questions, okay, and we'll solve some textbook questions. And this is chapter 8, motion of physics, class 9, okay. So just go through my previous videos to get an introduction of what this chapter is about, so that you'll get a better idea. So we'll move on to the questions directly. So this is page 100, page number 100 of NCERT CBSE 9 motion chapter 8, motion. Okay, the first question is, an object has moved through a distance. Okay, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. So an object has moved through a distance. Can it have zero displacement? You know what is displacement, right? Displacement means the distance between initial and final point. Okay. So an object has moved through a distance. Can it have zero displacement? Yes, it can have, because imagine a circular motion. Okay, imagine an athlete is moving across athlete is running along a track. Okay, so he started from this point and he's running, and again he came he reached the point A. So what is the initial point? Initial point is A and final point is A. So here, what is the displacement? Displacement is 0, because initial and final point is 0. So here displacement is 0. If yes, support your answer. You can show this example and support. Okay. For example, you can say an athlete running along a circular track. Okay, reaches the initial position after one round. So here the displacement will be 0. So an object has moved through a distance can have a 0 displacement also. Now moving on to the question number 2. What is the question? Question is, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Okay, so now here what it is? This is, a farmer moves along a boundary of a, first whenever you get these kind of questions, try to draw a okay, so that you will become there will be more clarity of the question. Okay, farmer moves along the boundary of a square field. So this is my square field. Okay, let's say A, B, C, D is my square field, and it is said that the boundary of a square field of side 10 meters. So squares all have equal sides, no? So this will be 10 meter, 10 meter, 10 meter, and 10 meter. Okay, so the farmer moves along the boundary of a square field of 10 meter in 40 seconds. So what is that? So my start position is A. Okay, from A my farmer is moving and he covered this full distance. That is what? This 10, that is 40 meter in 40 seconds. So what is first we'll write time taken to cover from starting from here. If we again come to A, what is that? One round, right? One round is what? It is given 40 seconds. So distance of one round is how much? The perimeter of the square. That is what? 4 into 10 meter, which is equal to 40 meter. And now what it is said, what will be the magnitude of displacement of the farmer at the end of 2 minutes 120 seconds? First, the total time taken, okay? Total time taken is 2 minutes 20 seconds. So we have to convert minute to second. That is 2 minutes is what? 2 into 6, that is 60 seconds plus 60 seconds. So 120 second plus 20 second is equal to 140 seconds. So the total time taken by the farmer in covering the whole rounds is 140 second. Okay, so the farmer started from here and is moving, okay, and he reached somewhere in the field in 140 seconds. It can be here, it can be here, anywhere it can be here also. So now we have to find the position of the farmer at 140. That is a final time, final position, right, in 140 second. So we know that what we know, what is that? We know, okay, we know in 40 seconds, okay. So you see, in 40 seconds, one round. In 40 seconds, the farmer covered one round, right? So now we have to find in 140 seconds how many rounds the farmer covered. So first, using the unitary method, we'll find. In 1 second, how much the farmer will cover? 1 by 40 rounds. So in 140 seconds, how much the farmer will cover? 1 by 40 into 140 rounds. Right? So 0, 0 cancel. This will be 2 and this will be 7. So this will be 7 by 2 rounds. So 7 by 2, if you do, how much? Look at 3, 6, 1. Okay, so it will be what? 3.5 rounds. 3.5 rounds, right? So what is 3.5? So see here, 1 round is this. 1 round, 2 round, 3 round, and then half round. So see again, 1 round is how much? 1 round. Okay, I reached again A, that is 1 round. Then again second round, reach again A. Then the third round, reached again A, and then half. 3.5 round means a half round is what? Here, right? So my final position is what? C. This is my initial position and this is my final position. So how much will be displacement? Displacement is the shortest distance between the initial and final position. So shortest distance is what? AC. So now we have to find AC. Okay, how we'll find AC? AC, how we'll find? Okay, I'll write it here again. So to find AC, you know that this is what? This is a square field, no? So square field is having a right triangle. So this will be a right triangle and this will be the hypotenuse. So here I have to find the hypotenuse. So here AC square is AB square plus BC square. So see, AC square is AB square plus BC. We have AB and BC, we can find AC. So we'll substitute. AB is 10 square, AB square 10 square and BC is 10 square. So how much it is? 100 plus 100, which is equal to 200. So AC square is 200. So AC will be what? Root of 200. You know what is 2 into 100? So 100 is what? 10 square. So we can take the 10 out. My answer will be 10 root 2 meter. So AC is equal to displacement. This is the shortest distance traveled by the farmer. okay, from the initial and final position. So is equal to 10 root 2 meter. So this is my answer. So you understood, right? So now moving on to the third question. What is it? Which of the following is true for displacement? So displacement is vector quantity. You know what is displacement? The shortest distance between the initial and final position. So which of the following is true? The first statement is it cannot be 0. Oh no, we have seen that this displacement can be 0 when the initial and final positions are same. So this is not true, this is false. And the second statement is its magnitude is greater than the distance traveled by an object. You know what is distance? Distance is a total path length, okay, and distance is displacement is the shortest distance traveled. So it cannot be greater than the distance travel. Maybe it can be equal to the distance travel in some cases, but it cannot be greater than. Okay, so this is also false. Okay, so now we move on to the textbook exercise of chapter 8 motion class 9, that is page number 102. Okay, we start on with the question number 1. Distinguish between speed and velocity. You know that what is speed and velocity. The first thing we say, what we can define speed and we can define velocity. What is that? Speed is a scalar quantity, velocity is a vector quantity. Now what is speed? The distance traveled by an object in unit time. So what is velocity? The displacement. Okay, the displacement of an object in unit time in a certain direction is the velocity, or the speed of an object moving in a certain direction is the velocity. And now the SI unit of they both are same, that is meter per second. And now what is the we can give the equation, that is speed is equal to distance by time, and here velocity is equal to displacement by time. Okay, the speed cannot be negative. Okay, speed cannot be negative. Okay, so but the velocity can be negative. Where the velocity can be negative? When we are moving in a straight line, and then again I'm coming back and going backwards, then there the speed can be the velocity can be negative, because the displacement will be negative. Okay, so this is how you distinguish between speed and velocity. So the second question is, under what condition is the magnitude of average velocity of an object equal to its average speed? So average velocity equal to average speed when the total distance and total displacement will be the same. So average velocity, average speed is what? Total distance by total time, no? So the total distance will be equal to, when the total distance is equal to total displacement, then average speed and average velocity will be the same. The third question, what does the odometer of an automobile measure? Odometer of an automobile measure the distance. Okay, distance travel, total distance travel is measured by the odometer. Don't make mistakes. Okay, speedometer is what? The measures the speed. Here odometer measures the distance traveled by the vehicle. Okay. The fourth question, what does the path of an object look like when it is an uniform motion? So when it is in a uniform motion, it will be in a straight line. Okay. So our next question is, this is page number 102. Okay, of physics motion chapter. So during an experiment, a signal from spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 raised to 8 meter per second. So whenever you have a word problem or a question like this, you first draw a diagram. Okay, so then the questions will be clear to you. Okay, so first what it is showing, I have a spaceship. Okay, this will be my spaceship, and the signal from the spaceship reached the ground station. So here I have a ground station. So this is my station, and this is my spaceship. Okay, so the signal from the spaceship reaches the ground station in 5 minutes. So the time taken for it to reach, the signal to reach, is 5 minutes. And also this the signal travels at speed of light, that is 3 into 10 raised to meter per second. So we have what? We have speed. Speed is given as 3 into 10 raised to 8 meter per second. Also we have time, which is equal to 5 minutes. So it is meter per second. We have to convert minute to seconds. That is 5 into 60, which is equal to 300 seconds. Okay. Now we have speed and time. We have to find the distance of the spaceship from the ground. Distance between. We have to find what? We have to find S, distance. So what is the equation of distance that connects distance, speed and time? You know, distance equal to speed into time, right? So distance, speed and time. So now what we have, speed is 3 into 10 raised to 8 into time is 300. So 300 into 3, 900 into 10 raised to 8, which is 9 into 100 into 10 raised to 8. So it will be, this is 10 raised to 2. 10 raised to 2 into 10 raised to 8 is 10 raised to 10, right? So 9 into 10 raised to 10 meter. This is distance, no? So distance will be 9 to 10 raised to meter. The distance of the spaceship from the ground station is 9 into 10 raised to 10 meter.